My name is James Orlando, and this is my data collection and measurement presentation on the Smithsonian Institute's David H. Kochs Hall of Fossils in the Natural History Museum in Washington, D.C. This is the modified and updated logic model because this is where it all develops from. Newcomer points out that logic models serve as a tool when designing evaluation studies and performance measurement systems. In this case, we're dealing with the world's largest fossil collection and 31,000 square feet of display space to optimize, with the goal of a modernized display, attracting more people than ever before, and increased interest in science, technology, engineering, and mathematics careers and degrees. This is the measurement table that has been put together, assessing two different research design questions and breaking down the data collection and measurement process. So the two things that we're going to be looking at is the idea of a modernized display, diffusion of knowledge, and a more interactive experience connecting with new demographics and promoting interest in STEM. The first research design question is, has the renovation achieved an increase in the diffusion of knowledge? This term comes straight from the Smithsonian strategic plan. The logic model component being measured is the idea of a modernized display aligned with current understanding of paleontology and the diffusion of knowledge through more visitors than before. The indicators to be used are if there are higher attendance numbers than before the renovation and participation numbers in interactive exhibits and programs. The source will be the visitors to the museum themselves. The method for attendance collection, or numbers for attendance, will be using volunteers at the entrances to keep track of how many people are visiting the hall, and a survey at the end of the visit assessing the visitor's experience. The timing at the end of the visit is key, as it strikes while the iron is hot, and visitors will be able to reflect on the most influential elements of the display without forgetting after perhaps another museum visit or afterwards when they are approached later with a mail survey at home or something like that. The second research design question is, has increased engagement and interactivity of the new display resulted in increased interest towards STEM careers or pursuit of STEM degrees? This question is going to be looking at the component from the logic model that refers to a more interactive experience, incorporating touch-friendly activities for kids and adults, connecting a new demographic and a 21st century audience with the material that's on display, and promoting growth not only in paleontology but also in other STEM fields. The indicator in this case will be increased pursuit of STEM careers and higher numbers of STEM degrees and majors being declared. The source would be the school groups that visit the museums, as well as the teachers that bring those groups. Universities would also be able to provide data in regards to degree pursuit, and then the visitors as well to provide data. The method to be implemented would be specially designed surveys for school groups, referring specifically to the things that have inspired them, or the elements of the display that have inspired them the most and intrigued them the most to move them towards STEM. If possible, these would also be combined with interviews and focus groups with school groups to get their unrestricted view on what they found most inspiring about the display. The key to this is that the people that are designing the survey may not necessarily realize what, in actuality, is the most influential part of the display. The interview and the focus group will hopefully highlight those. The information from the universities could be compiled into an interrupted time series design covering the years before, during, and after the renovation. One of the challenges with this evaluation will be ensuring validity. That is, that the renovated museum is the reason for the increased traffic and the interest in STEM. Ensuring good timing will also be critical. As mentioned earlier, it is much better to interact with the visitors and respondents immediately following their visit so that they're able to recall everything. Ensuring everyone is on board in terms of buy-in is also very important. Understanding that not only the attendance numbers and whether more people are attending is important, but also whether the data can infer what is the most inspiring and influential aspects of the display, and perhaps what needs to be modified to increase the inspiration and the drive towards STEM. For this evaluation, it's going to require a lot of time. You're looking at annual numbers and also a lot of resources, considering the face-to-face nature of the surveys at the end of the visit and the proposed interviews and focus groups. Another challenge is the influence of outside factors, such as market conditions, which may impact interest in STEM-related careers and degrees. If the market is looking for these degrees, then it may not be the renovated museum that's pushing people into those fields. A popular TV program can suddenly strike the nation's curiosity, and that could potentially influence inspiration and interest towards STEM-related activities. And then also school programs being introduced or apps that are being used on phones or iPads or something like that, that is also intriguing students and other people that may potentially pursue careers and degrees in STEM. And these are my references.